Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul Prashala, Solapur. I shall welcome to all of you in this session of 9th Standard Mathematics Part 2, that is Geometry. Today we will discuss on the topic Trigonometry Part 1st. Friends, in the previous standards you might have studied right angle triangle. Trigonometry is one of the important branches in the history of mathematics that deals with the study of the relationship between the sides and angles of a triangle, that is right angle triangle. The concept is given by Greek mathematician, that is Hipparchus. Today we will discuss with the following subtopics of this chapter, that is introduction to the trigonometry, terms related to the right angle triangle, trigonometry ratios, and problems from the practice set 8.1. So friend, let us start with the introduction to the trigonometry. Introduction to the trigonometry. We can measure distances by using a rope or by walking on ground. But how to measure the distance between a ship and a lighthouse, which are shown in the adjoining figure? How to measure the height of the tall trees? Observe the above pictures which is shown aside. Questions in the picture are related to mathematics. Trigonometry, a branch of mathematics, is useful to find the answers of such questions. Trigonometry is used in different branches of engineering, astronomy, navigation, etc. The word trigonometry is derived from the Greek words tri means three, gona means side, and metron means measurement. So friends, let us recall the things that you have been already learned in the previously. The subject trigonometry starts with right angle triangle theorem of Pythagoras and similar triangles. So we will recall those topics. You can see in the adjoining figure angle B is 90, means it is a right angle triangle. Using Pythagoras theorem we can write the following statement for this triangle, that is hypotenuse square is equal to sum of the remaining squares of the sum of the remaining two sides. Means you can write hypotenuse is here AC square is equal to AB square plus BC square. Here two triangles are shown, one with green and another with yellow color. So here in these two triangles, triangle ABC and triangle PQR are similar, then their corresponding sides are in the same proportions. So it can be written as AB upon PQ is equal to BC upon QR is equal to AC upon PR. These are important for study of this trigonometry. So friends, now we'll see terms related to the right angled triangle. In a right angle triangle ABC, angle B is 90. Angle A and angle C are the acute angles in both the one and the same figure, but angle consideration is different. Here in this angle A is considered, here angle C is considered, since angle B is 90 in both the cases. If you take this angle A, its opposite side is BC and adjacent side is AC, and adjacent side is BA, and AC is the hypotenuse. If you take the angle C, then opposite side is AB, adjacent side is BC, and hypotenuse is AC. So friends, in the above figure, here this triangle PQR which is shown here is right angle triangle. Write the names of the sides opposite and adjacent to this angle P and angle R. These two angles we are considering, and their opposite sides we have to write here. In the right angle triangle PQR, side opposite to P is this QR. Side opposite to angle P is QR. Side opposite to angle R is this PQ. Side opposite to angle P, adjacent to angle P is this PQ, and a side adjacent to angle R is QR. So adjacent opposite sides by consideration of the different angles would be like this. Here angle P and angle R both are acute angles, and for acute angle only we are learning this trigonometry. Friends, now trigonometric ratios. Trigonometric ratios are the ratios of the lengths of sides of a triangle. These ratios in a trigonometry relate the ratio of sides of a right angle to the respective angle. The basic trigonometric ratios are sine, cosine, and tangent. In short, they are said to be sine, cos, and tan. The other important trigonometric ratios are cosecant, secant, and cotangent, which are also called as a cosec, sec, and cot. can be derived using the sine, cos and tan ratios respectively. These other, that is cosec, sec and tan quad ratio, these are for the next standard. You could learn in the 10th standard. Friends, here we can see one right angle triangle. By considering the angle C whose measurement is given as a theta, here AB will become the opposite side, BC will become the adjacent side, and AC is the hypotenuse. Accordingly, the values of these trigonometric ratios can be calculated using the measurement of an angle, acute angle theta. In the right angle triangle, we will discuss them one by one. First is the sine ratio. The sine ratio of any given angle is determined or defined as the ratio of the opposite side to the hypotenuse. So in the given triangle, we can write sine of the angle theta can be given as sine theta is equal to opposite side upon hypotenuse. So here opposite side is AB and hypotenuse is AC. Friends, we'll see now the cosine ratio. The cosine ratio for any given angle is defined as the ratio of the adjacent side to the hypotenuse. In the given triangle, cosine of this angle theta can be written as cos theta is equal to adjacent side upon hypotenuse. So BC upon AC you can write. Third is the tan ratio. The tangent ratio for any given angle is defined as the ratio of the opposite side to the adjacent side. So in the given triangle, the tangent of the angle theta can be written as tan theta is equal to opposite side upon adjacent side, that is AB upon BC. Next, cosec ratio. The cosecant ratio for a given angle is defined as the ratio of the hypotenuse to the opposite side. In the given triangle, cosecant of the angle theta can be written as cosec theta is equal to hypotenuse upon opposite side, that is AC upon AB. Now next is sec ratio. The secant ratio for any given angle is defined as the ratio of the hypotenuse to the adjacent side. So in the given triangle, secant of angle theta can be written as sec theta is equal to hypotenuse upon adjacent side, that is can be written as AC upon BC. And the last one, cot ratio. The cotangent ratio for any given angle is defined as the ratio of the adjacent side to the opposite side. So in the given triangle, the cotangent of the angle theta can be written as cot theta is equal to adjacent side upon opposite side, that is AB upon BC. So friends, these are the different 6 ratios related to this. Now we'll see practice at 8.1. That is problem number 1. In the given figure, angle R is right angle and the triangle PQR. Write the following ratios: sin P, cos P, then tan P and this tan Q. Friends, we will write that first sin P is equal to, this is angle P. Sin means opposite to hypotenuse, opposite side upon hypotenuse. So opposite side is QR and this hypotenuse is PQ. Now cos Q, Q this means this angle. Cos means ratio, cos ratio is the adjacent side upon hypotenuse. So adjacent side of this angle Q is QR and hypotenuse is PQ. Tan P, this is tan P. Tan ratio means the opposite side upon adjacent side. As far as this angle P is concerned, the opposite side of this angle P is this QR and adjacent side is this PR. So we'll get the ratio QR upon PR. Tan Q, for angle this Q, tan ratio means opposite of this angle Q to the adjacent of this angle Q, which will be PR upon QR. Now next, problem number 2. In the right angle triangle XYZ, here you can see angle Y is 90, ABC are the lengths of the sides as shown in the figure. From that you have to write the following ratio, that is sin X, tan Z, cos X and tan X. So friends, we will see now sin X. Sin X means this angle. Sin ratio means opposite of this angle X to the hypotenuse. Opposite of this angle X is YZ upon XZ is the hypotenuse. So A upon C. A upon C. Now tan Z is opposite side of this Z to the adjacent side of this Z, this angle. Opposite side is XY and the adjacent is Y Z. So it will be B upon A. Now cos X. Cos ratio means adjacent side of this angle X to the hypotenuse. Adjacent side of this angle X is XY upon XZ. So B upon C. Now tan X, that is opposite angle of X to the adjacent angle of this x, which could be yz upon xy, which will be a upon b. These are the ratios. You can change the names, change these lengths, and we'll get the different ratios you can calculate. So next, problem number 3. In the right angle triangle LMN, angle M is 90, L is 50 and N is 40. Write the following ratios: sin 50, cos 50, tan 40, cos 40. So friends, we'll write these ratios first. Sin 50 means opposite of this side of this angle 50 to the hypotenuse Mn upon Ln. Cos 50, adjacent side of this angle 50 to the hypotenuse Lm upon Ln. Tan 40, opposite side of this 40 upon adjacent side of this 40, which will be Lm upon Mn. And cos 40, adjacent side of this angle 40 to the hypotenuse, so Mn upon Ln. So these are the ratios that we are getting from this figure. Next, problem number 4. In the given figure, angle PQR is 90 here. Angle PQS is 90. This PQ, yes, this is 90. PRQ, this is also 90. PRQ is alpha, and that of QPS is theta. Write the ratios: sin alpha, cos alpha, tan alpha, sin theta, cos theta, and tan theta. Friends, here we will get that this is a triangle given PQR. Here, first of all, we consider this triangle shown with pink color, and angle here it is alpha. So sin alpha is opposite side upon hypotenuse. Opposite side is this PQ, and hypotenuse is PR, PQ upon PR. And cos alpha, that is adjacent side of alpha upon hypotenuse. The adjacent side is this QR, or you may RQ upon PR. And tan alpha, opposite side of alpha upon adjacent side of alpha. Opposite side is this PQ, and adjacent is this QR or RQ. So you will get PQ upon RQ. Now one more, we have to this theta. That theta comes in this triangle different, that is triangle PQS, which is shown with blue color. This triangle now we will consider. So in this triangle, this angle P is theta. So you have to write the sin theta. Opposite side of this angle theta to the hypotenuse. Opposite side of this is QS, and hypotenuse is PS, QS upon PS. Cos theta is adjacent side of this theta upon hypotenuse. Adjacent side is this PQ upon PS. Tan theta is opposite side of this theta to the adjacent side. Opposite side is QS and the adjacent is PQ. So tan theta will be QS upon PQ. So friends, by considering different triangles, in these two triangles are there, individual triangles will consider and can be solved. So try similar problems by using reference material. Now, what we have been discussed today in this session is introduction to the trigonometry, terms related to the right angle triangles, then trigonometric ratios, and the problems from the practice set at point 1. Friends, will you try these problems? In the given figure, angle R is right angle of this triangle PQ. Write the following ratios: sin Q, cos P, and tan P from this. Second, in a right angle triangle LMN, angle M is 90, L is 50, and N is 40. Write the following ratios: sin 40, cos 40, tan 50. Now third, in the adjoining figure, angle Q is 90 here, angle PSQ is 90, angle PRQ, this PRQ, this angle is theta, angle QPS, this is phi. Write the following trigonometric ratios: first, sin phi, cos phi, tan phi. Secondly, by considering this triangle, sin theta, cos theta, and tan theta. I think these are the easy problems that I have already discussed. So try these problems. Friends, you should not forget the famous words that mathematics may not teach us to add love or subtract hate, but it gives us a hope that every problem has a solution. Friends, with these words I would like to say thank you. We'll meet in the next video. Till that, bye.